Figured it was time you meet the pooch. Hi, Wenju. Can you say hello? Can you say hi? It's the prettiest, best little girl ever. Can you say hi? Oh, you're so cute. All right, go play with your toys. Okay, so that's Miss Winnie June. You have heard her in the background many times. Okay, so let's get to the next video. So we're still talking about exponent square roots and order of operation, but this time I want to talk about understanding square roots. Now, we didn't mention this in the previous video, but if you have an exponent of 2, instead of saying this is blah blah to the power of 2, you could just shorten it and say, hey, this is something squared. So for example, if I had 5 to the second power, I could shorten it and just say this is 5 squared, and sort of saying it like that might help make this make sense. So understanding square roots. Okay, a square root is the inverse operation of squaring a number. So this is the inverse operation to squaring a number. And remember, in math, when we talk about inverse operations, these are things that will undo each other. So addition will undo subtraction, subtraction will undo addition. Multiplication and division, they undo each other. Squaring a number and finding a square root, they undo each other. Okay? So the definition for what is a square root? Well, the square root of a number is one of 2 identical factors of that number. We use a radical symbol, that's what this guy is right here, to indicate a square root. So what do we mean by this, one of 2 identical factors? Well, when you take a number and you square it, you're taking that number and you're multiplying it by itself. You have 2 identical factors. So if we had, for example, 5 squared, remember that 5 squared is really just 5 times 5, right? 2 identical factors. And the result when we multiply that out is 25. Well, now what we're doing is we're taking this 25 and we're asking ourselves, what are the 2 identical factors that make up 25? Well, we would say, well, 5. If I take 5 and multiply it by itself, I get 25. So the way we represent this to our reader is we use this square root or this radical symbol. The radicand is what goes under the radical. So I'm saying, what is this right here? This weird little symbol with a 25 under it is saying, what is that identical set of factors that gives me 25? Well, we would just say it's plain old 5. You don't list 2 factors, you just list what the factor would be. So in this case, 5. So my example here says the square root of 25 is 5 because 5 times 5 are those identical factors that give us 25. So example 3 says evaluate each square root. Let's go back to that multiplication table. There's something really, really important on it. So we've used this multiplication table a few times so far. So let's go back to it. It's got a little bit of writing on it. Let's see if we can erase it really quick. So we've got some junk on here. We'll get rid of the big stuff so it's not super confusing. Okay, so here's our multiplication table, and there's something really, really powerful that happens with this multiplication table, okay? So if we can start, let's go here. All right, I want to make sure the whole thing is there. If we can start with the whole multiplication table, and if we go down this diagonal, I gotta be really careful and make sure I actually go down the diagonal. If we go down this diagonal, we have the numbers that are the perfect square. So you really got to look at the ones that are actually the diagonals and not like all the other junk. But that right there, the ones that are truly on the diagonal, those are what we call our perfect squares. So perfect squares are numbers that have that nice, pretty whole number square root. Every number has a square root, but only certain numbers have those really nice, pretty ones. So for example, we were looking at 25 a minute ago. So if you go down the diagonal and you find 25, what you'll notice is the row and the column match. That tells me that's a perfect square. So this tells me 5 times 5 is 25. Let's try another one. Let's say we have, let's do 625. So 625 is here on the diagonal. Notice if we go all the way to the left and all the way up, we're in the 25th row and the 25th column. So that tells me 25 times 25 is 625. Therefore, the square root of 625 is 25. That's that identical factor. Okay, so that's that number. If you multiply it by itself, you'd get 625. Any number on the diagonal is going to do that, okay? So 144. We're in the 12th row and the 12th column. So that tells me the square root of 144 is 12. Okay, so you can use this multiplication now, obviously for multiplication. I've shown you how to use it for division, and now you can use it for square roots, perfect squares, as long as it's up, whatever fits on your table. So this is a 30 by 30 table, so it's going to have the perfect squares all the way up to 30 times 30, which is 900. Okay, so you are limited to the size of your table, but it can be used for square roots. All right, let's go back to the worksheet. Let's practice here. So the first example is the square root of 1. What number, if I multiply it by exactly itself, would give me 1? Well, that would just be 1, because 1 times itself is 1, okay? Now, the square root of 0 is kind of another wacky one. It's just 0, because 0 times 0 is 0, okay? So those are two kind of like freebies. Let's look at C and D. I did not mean to do this, but we accidentally did part D already on the worksheet. So let's go ahead and focus on part C. So what number, when I multiply it by itself, so I'm going to take a number and multiply it by exactly itself, what number is going to give me 64? Well, if you're really good with your multiplication tables, you will know that would be 8, because 8 times 8 is 64, okay? Further, if we go to the multiplication table, if you're struggling, we can go to the multiplication table, and we can go down the diagonal until we find our 64. Well, hot dog, we're in the 8th row in the 8th column. Look at that. 8th row, 8th column. So that tells me that the square root of 64 is 8. Okay. Now, I also want you to know how to do this on your calculator. Now, keep in mind, all calculators are different and they're going to do things very differently. I can only show you the graphing calculator that I have here. Anything else I'd have to show you in person. But if you do have this calculator here, each of the main buttons on this calculator does something, but then each button also has like a hidden function that it'll perform. So you have this blue second button. That's the button that you have to hit to get to that hidden function. And you know what the hidden function is on a lot of these buttons if you look in the upper left-hand corner. So let's look at this very first column of buttons. So starting at the bottom, we have on, and then we have store, and then we have natural log, we have log, and then we have x squared. Well, if you look in the corner of the x squared button, we have a little radical symbol. So that tells me if I use the blue button and then the x squared button, I'll get that square root symbol. So we're going to go second, and then x squared, that's going to pop in a radical. And then you just want to type in the number under the radical, which is technically called the radicand. So we would type in 64, and it's going to pop out that 8. Okay, so it's going to tell you what the square root is. So you can use your calculator, you can use your multiplication table. It's super helpful if you memorize some of these too, though. Okay, so 64 is one that's going to show up a lot, so it's worth memorizing. Now, finally, the square root of 144, we already did this when I was showing you how to use the multiplication table. The square root of 144 is 12 because 12 times 12 is 144. So you're looking for one of two identical factors of that number. That becomes the square root, okay? So make sure you understand just really basics with square roots. We're going to look exclusively at perfect squares for now. Those are the square roots that have those nice, pretty whole number answers. When we get into decimals and fractions, we'll continue our talk with square roots, but that's it for now.